So let us understand lateral displacement. So lateral displacement अगर आपने समझे, so we are saying that we have a glass slab which is having a certain refractive index and it is made up of a denser material. Denser medium का मतलब वो हो गया जिसमें speed of light कम हो जाता है. We have a rarer medium which is air and the ray of light is incident at a certain degree of angle of incidence. Now as the ray of light is traveling from a rarer to a denser medium, it is going towards the normal. So as the ray of light shifts towards the normal, it will follow a path like this and then it will again strike the glass air interface. And over here, it emerges back as emergent ray. So what we have done is we have marked out angle of incidence, angle of refraction, again angle of incidence at this point. Now since these two surfaces are parallel to each other, तो ये दोनों angle same हो गए, and then we have angle of emergence which is equal to angle of incidence based on law of reversibility of light. Now what we say? Now we want to calculate the lateral displacement, which is the perpendicular distance between the incident ray produced forward and the obtained emergent ray. तो ये जो perpendicular distance है between the incident ray produced forward and the obtained emergent ray is regarded as lateral displacement और इसको अपने कोई point को नाम दे देते हैं say u. Now let us solve to get the value of this lateral displacement which is LD. So if we start solving, let us begin by solving this triangle. So we are solving the triangle PRU. So in triangle PRU. So if we see in the triangle PRU, the only information that we have is the thickness of the glass slab which we regard as T. So if we know the thickness of the glass slab, then we need to know PR to solve the problem. In order to solve for PR, we again need another triangle. So we are also taking in triangle PQR. So if we take the triangle PQR, so I'm drawing a rough sketch of PQR. So this is 90 degree PQR and this is angle of refraction R. This is thickness of the glass slab which we have as T. तो अपने पहले यहाँ से PR कैलकुलेट कर रहे थे. तो अगर ये एंगल नोन है तो ये परपेंडिकुलर हो गया, ये हाइपोटेन्यूस हो गया, ये बेस हो गया. So over here if I write cos R, so cos R can be written as base by hypotenuse PR. So PR can be written as T upon cos R. Now let us come to this triangle which we have triangle PRU. तो अगर अपने triangle PRU को कंस्ट्रक्ट करें तो यहाँ पे वापस से अगर एक रफ PRU अगर अपने बना लेते हैं तो this angle is I minus R. This is the lateral displacement which we intend to calculate. This point is P, R and U. PR we have already calculated as T by cos R. So if we solve for this, then we write sine of I minus R is equal to LD upon PR. So therefore, the formula for lateral displacement will be PR times sine I minus R, that is T by cos R sine of I minus R. Now we can definitely calculate the relation between I and R using Snell's law. So if we apply Snell's law at this surface, so when we consider that this is refractive index mu naught, which is technically 1, so we can write mu naught sine I equals mu sine R, where mu is refractive index of the material of the glass slab. So using this information, we can solve for R and then we can substitute the value to calculate lateral displacement. Over here, the idea is clear that the lateral displacement will depend upon thickness of the glass slab, the material of the glass slab or the material from which the glass slab is made and the adjoining medium along with the color of the light used. So these are the information that is needed to calculate lateral displacement.
So now we are observing lateral displacement. तो lateral displacement का मतलब क्या हो गया? So if there is an incident ray, जैसे कि ये एक incident ray है, so if we produce the incident ray in the forward direction, then this is the direction of incident ray in the forward direction. But when we observe the emergent ray, then the emergent ray is somewhere here. So the perpendicular distance between the incident ray produced forward and the obtained emergent ray is called as lateral displacement. So this is a glass slab that we have, a rectangular glass slab. The ray of light first of all undergo refraction over here at air glass interface. where some amount of light is refracted and some amount of light is reflected. Then again it will travel inside the glass, and at the glass air interface the refraction takes place again from the denser to the rarer medium, and then we have an emergent ray. So if we produce the incident ray in the forward direction and the emergent ray, then we say that the perpendicular distance between the incident ray produced forward and the obtained emergent ray is called as lateral displacement. Now lateral displacement will depend upon several parameters. It will depend upon thickness of the glass slab. It will depend upon the angle of incidence. So if I change the angle of incidence over here, the lateral displacement is 0. So on increasing the angle of incidence, the lateral displacement value is changing. It will also change with the change in the color of the light used with the material of the glass slab. So this is the idea about lateral displacement. Using the concept of lateral displacement also, we can calculate the refractive index of the material of the glass slab by calculating the angle of incidence, the angle of refraction, and then solving the value sin I by sin R.